Okay, today we are going to continue our C tutorials and we are going to talk about structs, enums, unions, and typedef. So to begin with, we're going to talk about structs. They are one of the most important parts of C when we're, doing these Emerald tutorials because they are used constantly. Structs basically allow us to take a little bit of a more object-oriented approach to programming in C. It's not the same, but it's as close as we're going to get. They allow us to create objects that hold multiple different variables inside of them, and then we can instantiate multiple versions of this object type. I'm saying object, some people might be triggered by that if they're a little more familiar with programming in C, but I think for the purposes of a beginner, it's the best way to understand how structs are, how they function. So to begin with, we use the struct keyword, and then we declare the name of our struct. This is going to be basically a new type, kind of like int or car or anything like that. It's a new type. When we instantiate it, we have to use the struct type as well, but we use it as one. So this is the type of our struct now. This is a new struct, and then this is what the struct contains. It contains an int named numMoves. It contains a car named move1. That is a array with a size of 20. We can add more in here. We can add a bunch of ints. We can add structs inside of structs. We can add anything inside of here. The struct is basically like a container, and then we can make different versions of this container by calling the struct and creating a new variable. So this Charmander moveset, this is a variable of type struct movePull. And this Charmander moveset variable, we can give it, one move, and we can give it a name of the move, Fire Punch. And like we could add more entries here to be able to give it more moves, and we could do things in our code based on like, if there's an option for 20 moves, but you only have, int moves is only set to 7. When you're looking through this, you only, go through the first 7 or something like that, anything really you can do when we're using these. That's just kind of a little basic example of some logic that you could use. Here we access the data that are inside inside the struct variables. So when we create the new variable, when we create the new struct that we are going to be operating on, we instantiate it with some data. But if we wanted to just create it on its own and we didn't want to give it any data, we would just, declare it like this without anything, and then we would have to set its inner variables ourselves. So we would just go Charmander moveset dot number of moves is equal to 1. And this would set numMoves equal to 1. This dot operator is what calls the inner variables inside of the struct. So we can also do it in comparison. So if the Charmander moveset dot number of moves is equal to 1, then we run the code inside of here. And you can do anything that you can do in normal C, but with these variables. And it's just a nice way to organize them and contain them and make reproducible code that you can like copy in, so that you're not copying and pasting everywhere. You can organize things together. Now, you'll see in Emerald, we're not going to talk about it a ton because we haven't gotten the pointers yet. That's our next video. But if the struct is a pointer, a lot of the time this will be used instead of the dot operator. It'll be the little dash and then the greater than sign. And this is used because this dot operator takes precedence over typecasting from a pointer. So like it'll mess up sometimes. So in Emerald a lot, when the struct is a pointer to a struct, not an actual struct, which again we'll get into, but don't worry about it right this second if you don't understand what that means. If in that case, then we use this instead, just to avoid any potential headaches. So the structs are pretty powerful. They can store, a lot of different things, but since we're working on a bit of an embedded system, sometimes we need to have make sure that our data is contained efficiently. We don't want to have these giant structs with wasted data, especially if something like, say, needed to be stored in a save block. If the save block is only a certain amount of size, then the things that we store inside of it can only be so big. So we can create pack structs that are defined, that have actual bit definitions. So this creates a struct called flags. It instantiates it with a character, a data character, and this could be just, anything. It doesn't have to be here. But then down here, we have an int that's an error, and then we have this regular colon, and then 1. And then this means that this int is 1 bit, just a single bit, on or off. Here, this one's 7, so this is 7 bits. So together, this is 8 bits, and in memory, it's right next to each other when it's instantiated like this. This will be one 8-bit section in memory. And this whole thing together will be, because a car is 1 byte, it'll be 2 bytes, because that's 16 bits total. So we know that the struct will be 2 bytes in memory, and we can treat it that way. And we actually will talk about treating it that way with our next topic, unions. But so for structs, that's basically it for now. Obviously, we'll talk into pointers to structs. But they are used to create objects for us to interact with, and the objects can be, there are a lot of different possibilities. In the Pokemon world, if you just, start clicking on some C files, you will see structs used left and right. And that's something you should be doing to familiarize yourself with the code inside of the decompilation. But anyway, let's move on to unions. So unions are basically a way of creating multiple names for the same variable. So we define them a lot. It's got the same syntax as the struct. We use the union type. We give the type of the union. This is not going to be a variable. This is going to be a type, and this whole thing is the type that we define. This is actually a union that we create here, new flag, but this is the type. So this will be whatever the type of the name of your union. You'll have whatever you want here, and then inside of it will be the variable types that you want to be treated together. So what's happening is it's called a union because these two variables are, they're acting as the same. They're basically, this overall union is going to be a reference to one set of data that can be treated as either a struct or a U16-bit array here. So for an example of that, like if we declare this union, new flag, so this new flag, it is we can treat it as either as a struct here that we defined up here, this struct, so it can either be treated as this struct, or it can be treated as this U16-bit array, because again, this is 16 bits, we know that because this is 8 and this is 1 and this is 7. So this union here, these are the same size. If they're not the same size, the one that's bigger will obviously, it'll still fit, and the one that's smaller will have extra padded nonsense generally, depending on, the type, it'll be treating it as nonsense. Sometimes between the two, if you're substantiating, if you are assigning values that don't fit into one type, if they're going to be, like you're treating something as a bit array, and you treat it in a way that's going to be an invalid variable, like an invalid value for the other types, you might get an error if you aren't treating things correctly. But I should probably keep going before we talk about that, because I might be confusing some people. So we are going to declare this union, this new flag union, and then we are going to access it. We can treat it again as it's the same set of data, but we can set the different parts of it using the different names and the different types, instead of having to typecast all throughout our code, which is what you would be doing otherwise. but we don't have to typecast, and that's why this is created. So here we access the .newchar because we're accessing this part of the union instead of this part of the union. So we're .newchar and then .data because newchar is a struct flags. Struct flags has a data, so it's .newchar .data. So we're accessing this first byte inside of this new flag here. We're accessing the first byte of the 2 bytes that this variable takes up. And we're just going to assign it to an A because that works because it's a car, so it can take that as its variable. Now down here we're going to new flag bit array. So now we're accessing this. It's the same 2-byte chunk, but we're accessing the 2 bytes now as a U16, as a type. It's basically being typecasted. We are accessing the same chunk of data as a U16, and then we are going to OR equals, which is going to set this flag. This flag is going to be 1 moved to the left 8 times, which is actually going to be this one, because it's going to move 1, 2, 3, 4, 5, 6, 7, 8. And then it's going to set this error flag, hopefully. And it's going to treat, if we move this even further, it would change a bit inside of our character, and it would change what this is. If we set this to 12, it would affect the A. It would change the A. It shouldn't cause an error because all of them are defined, but it might not be a printable character or something. It might end up changing it to something weird. But we can access that variable directly through that. But if we just want to set this error, we can treat it as a bit array and set it that way. We could have always also done we could have done it through the flag itself. We could have done .error equal to 1, and that is perfectly valid, and it would have been fine. But there's just a lot of ways to do things in C for a reason, because sometimes doing it using a union is optimal to save time from all of the typecasting. And it's not necessarily optimal in space or processing power, but it can help clean up code, and they are used in Pokeemerald at times. So next, we are going to talk about the enums. They are pretty simple, but some people can get a little confused. We declare them a lot like the structs. We have the type, we have the name of the enum. This is going to be the type of the enum. This is not our variable. Again, we declare our variable with this full typing. And then we have the enum here. And it can be, you can put anything you want here. Just a common example is weekdays, so I used it. We have sun, mon, tu, all the weekdays. We could change these to whatever we want. Usually they're capital letters just because a lot of the time when we're using enums, we're replacing multiple defines. But these enums, they get treated when you assign this, like a value of the enum into a enum variable, they'll be treated a lot of the time as integers by the C code. Sometimes you'll want to typecast them to get the proper result, especially like when you're inside of an array. If you want to, if you wanted to use a constant, like a name, of a day of the week, instead of using 0, 1, 2, 3, 4, 5, 6 as your days, then you would use an enum like this, and you could change this throughout the code. So when the next day passes, you set it to Tuesday, then you set it to Wednesday, then you set it to Thursday, and then inside of your code, if you wanted to access a variable array depending on the day of the week, then you would have the enum here as your index in the variable. You would just need to make sure to typecast it to an int so that it would register it as whatever number of the day of the week it was. So that's basic enums. If you are confused about that, of course, just look it up. There are dozens of tutorials on each and every one of these things for C, because C has been around for a very long time. So people have been making resources to learn how to use it for a very long time. So lastly, we're going to talk about Typedef. It's a little similar to what we've been doing, like like I said with everything else. We are going to have 3 different declarations this time though. So we have the typedef keyword. This declares the fact that we are creating a typedef. And then we are going to have the type of what the new type is going to be, basically, and then the name of the new type. So here we use a basic example where we create a Boolean type. So here we use the typedef keyword. We're using int because at the end of the day, an int is, used as a Boolean, in C generally. So the int has the same properties as a Boolean. It's either 0 or it's non-zero. So it's either off or it's on. So we give it the name Boolean though, so then we can actually call things as Booleans. This is a variable now. It's a Boolean variable. The Boolean is technically an int under the hood, but we can use it as a Boolean. We can write Boolean for readability. And you might say, well, this is completely useless. Why would I do this when I can just, create it, as an int? And it's just for cleaning things up, for organizing things. Sometimes in more complicated things, especially the more complicated the typedef gets, it's important. We'll look at some of the ways PokeEmerald does it because I think it's interesting. But if we wanted to create a type that was a array of 10 integers, a 10 int array, we could create that. So this array we can now declare as a fixed array new array, and this is automatically an array of 10, of size 10. We don't have to create a new array every time. We don't have to, create it as an array. We can just we can just call this fixed array command, and we can create our new types. So why we, do that in PokeEmerald, we've talked about them before, the U8, the U16, the U32s, the U64. These are this is the typedef file that we use in PokeEmerald. It's an include gba types.h, and it holds all of the types that we use throughout the decomp. So the U8 that we use, an unsigned 8-bit integer, is actually by our C compiler known as the uint8_t, and so on and so forth. These are typedef volatile, U8, VU8. Volatile is kind of a keyword. We're not going to talk about it that much right now, but since it's here, I'll mention it. It's when we use it when a variable or type has to be constantly, when it has to be aware of potentially being changed at any moment from something outside of the program. So like, if we want our code to be able to, we don't want our code to break, basically, if some of the variables get changed outside of the code and we're not ready for it, the compiler wasn't ready for it, so it did optimizations that made it in a way such that the variable couldn't be accessed, or the variable being accessed would crash something. Things like that, we need the volatile keyword, and it's a little more high level. So if you're interested, definitely look it up, because like I said, it's a C thing, so there are certainly more tutorials on it, but it does get used somewhat often in the decomp, so it's important to at least be aware of the volatile keyword and what it generally does. But anyway, back to typedef. So we have these S16, these are just signed integers. Instead of unsigned, it's just a regular int. So S8 is a signed 8-bit value, S16 is a signed 16-bit value, and so on. We also have our floats, our F32, and our double is F64. These are the floats that we use in PokeEmerald. We have our Boolean values, we have our volatile Boolean values, and then here, even in this, we have some structs. So we have this typedef volatile struct, bag count, volatile bag count. We've got OAM data, which has got these bit fields that we were talking about. This is something that obviously I'm not going to get into, but it has these bit fields. They're U32s, but it only allows 8 bits of it. So that lets us pack all of this data really tightly. here are some defines. These are some, macros here. These set bit flags basically for the size of the different sprites. And all of this, all the rest of this isn't really that important. But yeah, so these are typedefs and how they're used in PokeEmerald. So that, I think, is all we're going to have for this tutorial. So we have talked about basic structures, we've talked about basic unions, we've talked about basic enums, and basic typedefs. If you have any more questions, be sure to leave a comment, but that is where we're going to leave it for this video, and we'll see you on the next one.